So here we have two objects which are placed at a distance of 2 meters from each other. So we have the value of small r or d, that is 2 meters. And we have the masses as 584. So we write m1 is equal to 500 kg and m2 is equal to 84 kg. The value of capital G is not given in the question, but we have to by heart this value, that is 6.67 into 10 raised to minus 11 Newton meter square per kg square. So this is the value that we have to memorize. What do we have to find? We have to find the gravitational force between them, that is denoted by capital F. So which formula do we use? The formula that we use over here is F is equal to capital G m1 into m2 upon r square. Now in the solution, what we have to do is we have to substitute the values. So we have to substitute the values, and after substituting we get G is 6.67 into 10 raised to minus 11, m1 is 500, m2 is 84 and r square is equal to 2 square. So now we write 6.67 into 10 raised to minus 11 as it is, and we multiply 500 and 84. So 500 into 84 gives us 42,000 upon 4, that is 2 square. Now what we do is we multiply 6.67 and 42,000, and the answer that we have is 280,140. What remains is 10 raised to minus 11, and in the denominator we have 4. So this is what remains. Now we have to calculate 4 and 280,140. That means we have to divide them. So after dividing them, the value that we obtain is 70035. Now 70035 into 10 raised to minus 11. Now in physics, whenever we have an answer such as this, wherein there is a power associated with a final answer, remember that this particular term has to be between 1 and 10. So is this number between 1 and 10? No, right? That means since the decimal is over here, we need to shift the decimal by 4 places so that we obtain 7.0035. Since we shift the decimal 4 places to the left hand side, that means we have to add 4 to this power. So we get 7.0035 into 10 raised to minus 11 plus 4, and 10 raised to minus 11 plus 4 gives us 10 raised to minus 7. And obviously we know that the unit for force is Newton. So what remains is the final answer or the final statement. So the gravitational force between the two objects is 7.0035 into 10 raised to minus 7 Newton.